Thank you so much for the opportunity. Hi, everybody. My name is Sundas Khalid, and as Lenka introduced me, I'm a data scientist at Amazon. And today I'm going to talk about online experimentation. It's one of my favorite topics. I currently work at Amazon's central A/B testing experimentation team, and I have been on the team for about 3 years, and I don't get bored at all. Just to tell you how much I love online experimentation, it's very interesting because I get to see company-wide initiatives and changes to the sites globally. So moving on, a little bit about myself. As I said, I'm a data scientist at Amazon. I'm specialized in online experimentation. I have been at Amazon for about 6 years, and this is my second team at Amazon. And previously, I was a data engineer before I transitioned to data science. I'm also a mom of two kids, a boy and a girl. Something that I like to do on the side, I like to give talks, whether those are motivational talks, tech talks, and including this talk. So I also do lifestyle and data science blogs on the site. You can read my blogs on my website. Besides my work and all the other stuff going on, I'm very, very involved in diversity and inclusion efforts. Within and outside of work, I currently lead the Pakistani Women in Computing Seattle chapter, and I serve on the board as vice president. I also serve on the board for President's Advisory Board at the North Seattle Community College, which is a local college here in Seattle. At Amazon, I'm part of the Amazon Women in Engineering core committee. And recently I was featured by Programmer and People of Color in Tech to highlight as a women to watch. Most of you, if you guys attended GHC, it's one of the biggest tech conferences host for women, hosted by Anita Viorg. And I've been going to GHC for about 4 years now. This was my 4th year. And this time I was a session chair for Tech for Women track at GHC 19. So this is it about me. I have shared my website. It's sundaskhalid.com/about-me. If you want to learn more about me or get in touch with me, feel free to go to my website and connect with me on LinkedIn as well. Okay, so let's move on. So agenda for today is, since we're talking about online experimentation, I'm going to give you a little bit background into different types of experimentation, what is online experimentation, and what are the business use cases. And I also feel it is important to cover the statistics because stats is core to online experimentation. So I'll just give you a little bit overview of stats. Most of you have probably taken it in school or college. Then we'll just quickly walk through what is the life cycle of running an experiment and opportunities in my existing team at Amazon. Cool. So talking about types of experiments. The most basic one that you probably have heard so far is the lab experiments. So lab experiments is basically exactly what they sound like. They are done in a lab. They have a controlled variable test and they are conducted within a lab. Then we have field experiments. Field experiments is basically you are actually going into the field and you are observing. So one example would be that an experimenter might have a person pretend to fade and observe to see how long it takes the onlookers to respond. And you probably have seen some TV shows where they do these type of experiments. So these are called field experiments. Then we have quasi experiments. These are basically, you study someone from birth. So let's say there are two twins, and then you start studying the two twins from their birth to age 21 and see how their personalities evolve over time. And then we have online experiments. So online experiments is basically you're running that on a website. It's very similar to lab experiments because we have variables that we are controlling. It is also called A/B testing because we are doing a version of the site, which is A, and another version of the site, which is B. So that's why it's called A/B testing. Some people also call it split. There's actually a company called Split that's full. There's Split, and then there's Optimizely. Their core job is to build a platform for A/B testing for online websites. So let's talk about online experiments, also known as A/B tests. Let's say if you were to Google online experimentation, this is what you will find. The Wikipedia definition is You can read it too, but I'll just read it for the sake of it. It's a web-based experiment on, or internet-based experiments that is conducted over the internet. This form of experimental setup has become increasingly popular because researchers can cheaply collect large amount of data from a wide range of locations and people. A web-based experiment is a type of online research methods. So some of you probably understood it, some of you probably didn't. So let's break it down. So online experiment is basically you are trying new things on your website, and you want to see how customers behave to those changes on the website. This is a very simple definition. If you're just starting out in an online experimentation space, just understand that it is just learning from your customer after you make changes to your website. So as I said, experimentation starts with an idea that powers to do something, like you want to sell a product, or change someone's mind, or build a relationship. You want to know if this idea is great, will it work? If it does, how well and how fast? Is it one step toward a better idea? If it doesn't work, what can you learn from that? So now I want you to think of these questions throughout the session, because when we talk about online experimentation, we're really talking about ideas and inspiration, how you connect your thoughts, your ideas with your customers. And number two, online experimentation is just one part of the product improvement lifecycle. Whatever the results are, always consider how you can build on top of that. So let's talk about some business use cases. The reason you have an idea is because you probably have some business use case that you want to test, whether, let's say, you are selling a product and you say that if you change the product description from A to B, you think the product will sell more. So that's your business use case. And those ideas are in experimentation terminology, it's called hypothesis. And your expected outcome. So for example, increasing sales by showing X, or improving user experience by doing something on the website, or you just want to improve the click-through rate by improving some experience. So these are some examples of your business use cases that turn into hypothesis that you are testing with A/B testing. So let's do a case study. So this is Humana. It's an insurance company. It's not related to Amazon. I just picked this up from an external website. So Humana is an insurance company, and they want to improve their click-through rate, because so the one that you see on the left, the saves the prescription drugs, this is what they had on the website before. Okay, so they changed, so that's their control, but they wanted to, but people, they expected that if we change the image or if we change the text, there will be more click-through rate, people will be more engaged. So they introduced this treatment, which is this, they are just changing the background image, which is more, as you can see, it's higher resolution, and they're changing the text slightly. So by doing this, they're just cleaning up their site. And they experience, with this change alone, they experience an increase of 433% with just the picture, not text. And then after changing the text, they experience another 192% click-through rate. So this is just one example of how powerful changing a very small user interface on your website can lead to a big wins for the company. So A/B testing is basically you show your customers A and you show half of your customers B, and then you observe how they are behaving in an A group and B group, and then you observe their the outcome against the expected outcome. So before we go more into experimentation lifecycle, let's talk about statistics. In order to run experiments or to understand how hypothesis tests work, it's very important that you have your statistics 101. And we give this training to pretty much everybody at Amazon who is planning to engage with experimentation, whether those are software developers, data scientists, or they are program managers or product managers. So what is statistics? So this is going to be, it's very basic. This is just going to be a refresh of the classes that you took in high school or colleges. So statistics is a reasoning about uncertainty. It's a science of probability. And uncertainty comes from the population. Okay, so probably most of you or some of you didn't understand what I just said. So let's go through an example. So let's say you are sitting in the Husky Stadium watching the game, and Huskies are winning. You're very excited, and in all of this excitement, you have this idea. You come up with an idea that you want to measure everybody's height that is sitting in the audience. Because let's say maybe you have some hypothesis that the average height is in the audience is about 6 feet or 5 feet 8 inches. So what will you do? Ideally, you can measure everybody. You would want to measure everybody that is sitting in the audience. However, that is going to take you a long, long time. And it's probably not feasible because it's going to be expensive to measure every single person's height. So instead you say, okay, I'm not gonna do everybody. I'm not gonna measure everybody's height, but instead what I will do, I will take the people sitting in that corner. So if you see that purple circle that I created, so you will say, okay, I will not measure height of everybody sitting in the audience. Instead, I'll just measure the height of people sitting in that right corner. Now here you are just saying that people sitting in the right corner are representative of the entire population that is sitting in the audience. So this is the people sitting in the blue corner, in the purple corner are your sample size. Since you cannot measure the entire population, you are measuring a small sample size. So, and then you will measure their height, and then you will see what is their average height. And you will say the average height of the population is this. Now, the problem with that is that it's a representative sample. And there's some sort of uncertainty that comes with it because it's not 100% of the population. So in order to make sure you're not making a mistake, you need statistics to remove that uncertainty. So when I say remove that uncertainty or reduce the or increase the confidence, you actually need statistics to do that. So let's keep going. Let's talk about describing a sample. So a sample was the purple corner that I showed you. And here are the descriptions of a sample. A sample has the following characteristics: a sample size. So a number of elements in the sample. So let's say we count this purple circle, there are 1,000 people sitting. So that's your sample size, and that would be the elements in your sample, 1,000 people. The mean would be the arithmetic average value of your sample. That would be basically the average height of those 1,000 people. The median is 50th percentile. Mode is the most common value. And then variance is basically the measure of the spread of your data. So let's see on the right side, you will see two curves. Both of them are bell curve, but you will see that the one with the dashed is more spread out. It's wider than the one that is in the solid line. So now when we're talking about the variance, which one would you think would have the higher variance? The one that is more spread out was going to be have the higher variance, because the height or the speed in this plot that we have is it ranges from 20 to 90. Compared to the solid line, the range is from 30 to 70. So that's what we mean by the variance. And then the standard deviation is basically the square root of the variance. Okay, so I added this quick quiz. I hope you guys can answer this. So on the following two histograms, what is the mean, median, and mode? So the one on the left side is bell curve shaped, and it's centered. So the mean, median, and mode for the left graph would be in the middle. It will all be the same. Now, when we're talking about the right, I would like you guys to tell me what it would be. Would it be middle, left edge, or the right edge?
Okay, I think we can close the poll. Most people have voted. Let's see the results.
Okay, awesome. Most of you are correct. So it's the middle would be the median would be in the middle. Okay, and then the mean would be somewhere on the left hand side. And mod will also be on the left hand side because mod is the highest number. All right, so great job there. Exactly what I said. So for the left curve, the mean, median, mod would be in the center. For the right curve, it will be on the left edge side. Okay, so let's talk about hypothesis testing. So as I explained, hypothesis is basically an idea that you come up with. So let's say your hypothesis is, do men and women's height differ? And in statistics, this is how would you write. Your hypothesis is, your null hypothesis is height of men equals to height of women. And your alternative hypothesis is height of men is not equal to women. And in the second example, we have, are men taller than the women? So in this case, our null hypothesis, height of men is less than or equal to height of women. And our alternative hypothesis is height of men is greater or equal to height of women. Now in this, you would see that your null and alternative hypotheses are actually mutually exclusive. If one is not happening, then the other must happen. There is nothing in the middle. So when you're defining your hypothesis, you need to make sure that your null and alternative hypotheses are mutually exclusive. And in theory, your alternative hypothesis is basically the hypothesis that you want to test. And if that your hypothesis is not correct, then if the alternative is not true, then the null hypothesis must be true. So most of you probably heard of p-value. So in statistics, p-value is heavily used. So p-value basically means the probability that if the null hypothesis is true, your sample differs by as much as you're seeing or more. So as I mentioned about uncertainty, and we need to, since we have a sample population, we need to use some sort of statistics rigor to get the confidence in the learnings that we're deriving from this population. Okay, so we use one of the most common industry-wide used statistics test is two-sample t-test. And that two-sample t-test will give you a p-value, and the industry standard is normally a threshold of 0.05. And you will use that threshold to see if the results that you're getting and what is the p-value on that. If the p-value is less than 0.05, you will say that your alternative hypothesis is true. And if your p-value is greater than or equal to 0.05, then you will say your null hypothesis is true. And we say that results are statistically significant when the p-value is less than 0.05. So let's say, let's take an example. So p-value of 0.04 versus p-value of 0.8. So a p-value of 0.04 using the industry standard of alpha 0.05, we will say that p-value of 0.004 means the results are statistically significant. And if the p-value is 0.8, we will say it's statistically insignificant, that there's not enough evidence. So when you're using p-value, there is possibility that you will make mistakes. As I said, that we are not measuring the entire population, we're just measuring the sample population. So, and then you're using statistics on top of it, and you're defining some alpha and using that alpha to evaluate the results. You are going to make mistakes. So in like very typical errors that you will see when you're using p-value is type 1 and type 2 error. So a type 1 error is basically, let's say, so okay, let's say you're running an A/B test and you see results. There is actually no real difference. The men's and women's height is actually the same. That's the reality, and your results are insignificant. In that case, this is actually a good thing. So it's a smiley face. And the type 1 error you will actually make if the results are significant. You are seeing a p-value of less than 0.05. but there's actually no real difference between men's and women's height. So in that case, you are going to make a type 1 error. A type 2 error is related to power. So that could be that maybe the sample that you have, you don't have enough, you don't have a representative sample, or you have a lot of variance in your data that you're not able to get enough power. So in that case, there's actually a difference, but your results, you're not able to find any difference. So your p-value is insignificant. In that case, you will say, okay, I will reject the alternative hypothesis because it's insignificant. So you can make a type 1 or type 2 error because of p-value or because of the power. So I mentioned power. Let's go a little bit more in depth in what I mean by power. So power basically is defined by 4 characteristics. First one is the sample size. So the sample size is, we said that there are 1,000 people whose height we want to measure. You can think of it like larger the sample size, the more power you're going to have. Because once you have more people in your sample, you actually have a large population to test on. A smaller sample size means you will have less power. And variability of your metric. So variability is what I mentioned by the variance. So we saw two curves. One was more spread out and one was less spread out. So now in this case, the one that was wider spread out, that will have more variability. So if you have more variability, you're going to have less power because it's going to hard to detect, come to an average and have a significant p-value on it. So less variability equals to more power. Magnitude of the size of the effect. So by that, I mean is basically, let's say if you're making some changes on your site, but it's a very small change and people don't even notice it. So in that case, they're not going to change their behavior. However, let's say if in a different case, you are making a very drastic change and people are going to react very differently. So in that case, the people in your control and treatment group are going to have very different behavior. So it's easier to detect a difference, a significant difference in that kind of scenario. So a bigger the effect, the more power you will have. And type 1 tolerance that I told you about, it's more willingness to get a false positive. So as I said, the industry standard is 0.05, but sometimes people change that p-value threshold and they can increase it. They will say, no, I want to use 0.1 threshold. In that case, if you change the threshold, you're going to increase your tolerance for making a type 1 error. So those are some of the things that you need to watch out when you're trying to analyze your results or you're trying to figure out what alpha and what p-value threshold that you want to use. So I kept talking about significance. So there are different types of significance tests. Basically, the most common one is the 2-sample t-test. You can use a t-test which is based on the p-value, and it will tell you if it's significant or not significant. And that p-value alpha is basically you will define. Then there is something called Bayesian statistics. I don't know if you guys have heard of it, but Bayesian statistics is basically, it takes into historical information into the consideration when it's telling you if it's significant or not. So here's an example of Bayesian statistics. So in p-value, the plot that you see, observed data, when you use a 2-sample t-test and you use a p-value with that, you're basically looking at this graph only, that one in the orange. Okay, but in Bayesian, we're actually taking into consideration prior beliefs. So what they're saying is that before this experiments, customers also had some behavior. We want to take that behavior into consideration when we're trying to conclude our current experiment, that we only, let's say we ran the experiment for 1 week, but we also want to take into consideration what those customers that were part of this experiment, how they behaved in the 2 weeks prior to getting introduced into the experiment. So that is basically Bayesian statistics. There is some prior beliefs that we want to take into consideration when we are making the decision. And it's the Bayesian statistics are actually becoming very popular across the industries, and not just at Amazon. Like there are different companies such as Airbnb has been doing a lot of A/B testing. Microsoft has team as well. So it's the industry-wide Bayesian statistics have been getting more and more popular because of the historical information that we can get from the online data specifically. Okay, so what does running an online experiment looks like? So this is basically online experiment lifecycle. You start with the problem identification. You say, okay, this is the problem that you want to solve, whether that can be a business problem, you can think of it as a business use case. From Amazon standpoint, we can say that there are a lot of people who are coming to the checkout page, but they are leaving the checkout page without completing their purchase. So that's the problem that you're trying to solve. Now you come up with a hypothesis. You say, okay, maybe if I make this certain changes on the checkout page, customers will not leave the cart. So that will be your hypothesis. And based on that hypothesis, you will set up an experiment. You will send some customers to control. You will send some customers to treatment group, and then you will run that experiments. Let's say you run that experiment for 28 days. You will observe how customers in control and treatment behaved. You will see if the treatment customers actually bought more now that they are seeing that change in the add to cart or the checkout page. And then that will be your data analysis. You will run your t-test or your Bayesian statistics on your data analysis, and after looking at the results, you will decide if you want to launch that feature to all the customers or not. There are two stages to experiment design. One is the pre-experiment, and the later one is the post-experiment. So in your pre-experiments, you basically, as I said, you set the hypothesis, you figure out what your expected sample size and power is, what is your triggering logic. So I didn't talk about triggering logic. So triggering logic is basically, you say everybody, so an example of a triggering logic could be a customer who lands on the checkout page is automatically enrolled into this experiment. So that's your triggering logic. Or another triggering logic could be, if you have, let's say if you're testing something on the footnote or like bottom of the page, you can say everybody who scrolls down the page all the way down is going to be part of this experiment. So that is basically your triggering logic. You figure out how you want to enter a customer into the experiment. There is obviously like different kind of triggering logic that you can have. Like, for example, we only want to test on non-prime customers, or we only want to test on prime customers. So you can actually define and figure out what your triggering logic is and who is your target audience is. We also, like, one of the important things is that you need to define your launch criteria. Basically, what is your decision strategy? How are you going to decide, let's say, because we don't wait until the end of the experiment. You want to decide these things before, because what happens is after you run an experiment, you have invested a lot of time. You as a owner of the product is more inclined to launch that feature because your team worked on it, you tested it. Now, maybe it didn't meet the launch criteria, but you still want to launch it because the team worked on it. So we, like, one of the general policies is that you define your launch criteria before you actually start testing when you have not seen the results. So a launch criteria would be, let's say, if I increase the revenue by X% and it's significant at p-value 0.05, then I will launch. Otherwise, I will not launch. And then the last one is the duration. So duration depends on the power and the sample size that you have. So duration would be, you want to run this experiment for 1 week, you want to run this experiment for 2 weeks, or let's say 4 weeks, or if you want to run it for a longer time period, 6 months, because you're running some study. So these are all the things that you need to define pre-experiments. And then let's say you run your experiment and now you have your post-experiment phase, which is you do the data analysis, you learn and deep dive, and then you make a decision to launch or no launch. By the way, I'm saying all these things because these are very, very important. And actually one of the interview questions, most of the data science interviews, one of the interview questions is about experimentation. And they won't specifically ask you to design an experiment, but they will say like, okay, I want to check the incrementality test. How do I do it? So all this knowledge is actually important when you're trying to explain your A/B test design. and how you would like go about testing the incremental change. So it may sound like it was very easy. You just send some customers to control, send some to treatment, and then you just do the analysis. Well, it's actually pretty hard because few things. One is that noise. You can have some noise in the data. And one example would be, let's say at Amazon, we have like Thanksgiving, we have Black Friday, we have Cyber Monday, and Microsoft, I'm sure there are other like seasonality. And let's say if you're running your experiment during a peak season or a off season, then you're going to introduce a lot of noise into your experiment, and it's going to be hard for you to decide what exactly is happening. It is also pretty challenging to figure out what exactly you want to measure. Is it the revenue? Is it the click-through? Or is it all of them combined? And that's something that as a business owner, as a product owner, as a person who owns the experiment, you have to come up with that. So it sounds pretty easy, but it's actually not. You have to take several things into consideration. And then because of that, decisions will involve trade-offs. So you need to think through what exactly you are willing to trade off in order to achieve something. Okay, so I gave an example of checkout page. So this is how it would look like. We will figure out what exactly do we want to measure. We would say like we want to make Amazon more valuable to customers. So we will have control and treatment group, and then we will come up with some proxy metrics. We will say, okay, we want to proxy on the revenue. We want customers to be more engaged. We want them to spend more time, and we want them to revisit. We want them to like revisit the site again. So all these things you have to take into consideration and figure out what exactly you are trying to improve on. You can try to optimize for everything, but you need to figure out what is your like priority level and what are you willing to compromise on. I'm going to skip through some of these because we are a little short on time. So some caveats in A/B testing that you should watch: short-term versus long-term measurement. So let's say you run the experiment for 10 minutes to 1 day. You're going to observe some treatment. Okay, so let me explain it this way. So let's say you are a customer of Amazon, you go to Amazon site and you see this very beautiful change on Amazon that you really, really like. You click on it and you do some activity on it. Now, let's say you come back tomorrow and you see the same picture again. Are you going to act the same way? Are you going to behave the same way? Let's say you come back the third day, the fourth day, 1 month from now. You're going to be so used to this change that your behavior is not going to vary that much. So that's what we mean when we say the short-term versus long-term behavior, because customers may act different in the short term versus what they would do actually in the long term. So you have to watch out because the nature of the experimentation, most of them we run in the short term, let's say 2 weeks, 3 weeks. You need to watch out, also worry about the long-term impact, how this is going to impact. Once you introduce this feature to the site, it's going to be there forever until somebody else touches it. So you need to understand how it's going to impact customers in the long term. And it's called time varying treatment effects. Some of it is novelty effect, because sometimes when you change it, the change by itself has an effect. There is also like customers learn. So once you show them something, there will be a learning curve, and once they learn, they will start behaving differently. For example, we're introducing a new UI. And sometimes we're just testing ads and we're showing customers ads, but some customers are numb to ads. It's called ad blindness, and they won't even care if they're seeing the ads or not. So those are some of the things that you need to watch out. And then short-term actions may have a long-term effect. For example, let's say on Amazon, we're giving away free Prime memberships, and we run that experiment for 2 weeks. In the short time period, there's not going to be any financial impact because we gave the membership. But let's say if after 30 days or 40 days, a lot of those people end up canceling their free membership, then there is actually no gain to Amazon from the revenue standpoint. So those are some of the things that you need to specifically at Amazon, we need to watch out for, because when we're running testing in a short time period, we need to like consider the long-term effect and how it is going to change customers' behavior over time. There is also something called multi-arm banded. So you probably are wondering, why can't you just run a multi-arm banded when you're changing pages on Amazon? So think of it this way. So Amazon A/B testing optimizes for human learning. So you are making some change, humans react to it, and you learn from it. In Maps, we're optimizing for regret or return. So what I mean by regret, so you're basically making, most of you, if you've seen what multi-arm bandits is, you have a page layout, and it's powered by a machine, and the page layout will keep changing based on the customer reaction to the content on the page. So the page will keep optimizing. So that's the main difference between A/B testing and MAB. A/B testing in general is more, it's probably better for like learning standpoint, because then you can, let's say if you test one hypothesis, you can actually, the next time you can iterate on it, and you can learn from it how customers behave to different features differently. In a MAB, it's done by a machine. It's more in a continuous fashion. So there is not much time for you to learn. And it's mostly uses single object function. And a post-experiment analysis in MAB becomes slightly challenging because of its continuing changing nature. So some final thoughts. Online experimentation has become fundamental in a lot of industries for learning user behavior. Many companies are using A/B, have built their own platforms, including Amazon, Airbnb, Facebook, LinkedIn as well, to test features on their website. And they use those experimentation to actually learn how users like and how users behave. It may sound easy, but you can actually make mistakes. You need to watch out for common pitfalls, such as biases, type 1 and type 2 error, short-term versus long-term treatment effect. One of the core data science areas is online experimentation. And as I said, it's one of the common interview questions. And the terminology that you have to look for when you're in an interview and somebody's asking you a question is incremental. They will say, okay, how would you measure this change, incremental change in this, in X? And that is basically an A/B test question. So just remember that if you are getting thrown the word incremental, they're talking about A/B testing. Now I had this quiz, but I will ask and answer myself. So just to wrap things up. So let's say you have a control. In control, you have a mean spend per shopper is $1. In treatment, you have mean spend per shopper $1.05. Now the difference between mean spend treatment minus control is $0.05. Now, do we say that the treatment is actually doing better? Do we say that we should launch the treatment? Because treatment is actually spending 0.28 cents more than the control, 0.05 cents more than the control. It might be on the surface, it may seem like, okay, treatment is the right thing, we should launch it. But no, you cannot do it that way. You need to actually apply more statistics rigor on top of it and watch out the caveats, and then you need to conclude your decision. Okay, so that's all I had on online experimentation. I do have, as I said, like my team is Amazon Experimentation and Optimization, and we have our own dedicated URL where we post open jobs. So if you are interested in Amazon, or if you're interested in specifically in experimentation team, you can go check out that URL. We have the open recs include economist, applied scientist, software developer. So feel free to apply, and that's all I have. Thank you so much. And my website is sundaskhalid.com. Make sure to connect with me on LinkedIn and follow me on Twitter. Thank you so much.
Thank you, Sundas, for the presentation. And now we will take questions. So anyone, you're welcome to pose your question. Ideally in the Q&A section. Yes, there's one. Do you have access, Sundas, on your side to the Q&A? Can you read those questions?
Okay, so the first question is, what specific sampling methods is being used to make sure samples represent the population well? Okay, so this is a great question. We can do different stratified sampling is one example. There's region-based sampling. So it depends on the problem that you're trying to solve. Let's say we're talking about Amazon and we're talking about our homepage and we're testing, let's say we're adding a new picture to Amazon homepage. I am going to use random sampling for that. So that random sampling is basically anybody who enters the homepage, lands on the homepage, I'm going to randomly send that person to control and treatment. So that's called the random sampling. But there are other sampling techniques that you can use. However, that depends on your business use case and the problem that you're trying to solve. So definitely read up more on it. But one of the most popular and common sampling technique is the random sampling. Second question is, how do you define the duration and sample size of your test? So this duration, again, a lot of it has to come from you as a business owner. And let's say you're a product manager, it's your product. You get to decide. Running an experiment is expensive because let's say if you run an experiment, there is a hardware cost associated with, you have to store the data somewhere. You have to have dedicated people who are going to write the code for the triggering logic, people who are going to monitor the experiment, and then there will be people who have to do the analysis. So running an experiment is inexpensive. And beyond that, you have to, a lot of the times you can only test one feature on one page at a time. So your other ideas have to be in the back until that idea is tested. So a duration is a combination of you as a business owner decide how long to run an experiment. And the second is the sample size that you're going to get and the power that you're going to get. So before in Amazon, generally, before you actually start running your experiment, we ask you to come up with your sample size. We ask you to expected sample size. We ask you to come up with the p-value threshold and the difference that you're expecting to see in your control and treatment customers. And after that, we ask them to do a power calculation. And based on that, we provide them the duration, suggest them a duration. Okay, this is, let's say your sample size is 100,000, and you are expected to see this much different. We recommend that you run this experiment for 4 weeks to reach power. So it's a combination of a lot of things. I know, like, you can also say, just randomly say, like, you want to run it for 28 days, but it's better if you put some thought into why you chose 28 days or why you chose 1 month to run your experiments. Another thing I want to call out, like, some companies like to do full week experiments because depending on the business, the nature of the business, your the way customers behave on the weekend versus how they behave in weekdays would vary. So a lot of the companies, they try to run experiment for a full week duration. Let's say if they started on a Saturday, they will make sure to run it until the Sunday. So they have a complete 7 days to do the analysis. So that's something also to, like, keep in mind when you're setting your duration. And if those are like in the multiplications of 7s. Okay, so the next question I have, can you describe some real scenarios in which FP is more tolerable FN? Sorry, I didn't understand. What do you mean by FP? False positive? Okay. Okay. Could you define could you describe some real scenarios in which false positive is more tolerable than false negatives? Okay, so I think the real world example of it would be, so a real world example of false negative, where false negative would be more, would be worse than a false positive. Let's say you're running some experiments on non-prime customers, and you're making some changes to the website. Now, your hypothesis is that customers, if you make some change to the website, the customers will come back to the site more often and they will become prime eventually. However, what actually ends up happening, your change is so horrendous that people stop coming to the website. In that case, maybe you're not able to observe that because they are non-prime customers and they don't come to the site back very often anyway. So you make a conclusion that, oh, your change actually is good for the customers in some way, and the data point that you're getting is saying that, okay, the customers are actually coming back to the site, or they are purchasing more even though they're not coming back. In that case, customers are actually not coming back to the site, and there is going to be a downstream impact associated with that. So you need to watch out that if you're losing a customer and that kind of mistakes, you actually don't want to make because when you're losing a customer, you're not just losing what will happen during that experiment duration, you are also losing what will happen 365 days or 2 years from now because that customer does not exist in Amazon anymore. So I know like these are extreme cases. But these are also like edge cases where you would have like false positive and false negative being so far off that you would wanna eventually like avoid your false positive and false negative by using a p-value that is rigorous enough so you have enough confidence, or you want to use Bayesian statistics where you have more information on your customers and your samples so you can make an informed decision. Okay. So the third question is, at what point do you decide to stop the test? Imagine you're not observing significant results for a period of time. Okay, so let's say you're running this experiment and you are not seeing any difference. So there could be either two things. One is actually customers don't care, there is no difference. So that's why the results are not significant. So in that case, you can actually conclude that your alternative hypothesis is not true. So you should reject your alternative hypothesis. So you can stop the experiment. But again, like before you get to the point where you have to keep looking and keep checking, you should define all these things beforehand. Like in your pre-experiment phase, you should decide all these things beforehand. What is your exit strategy and what is your decision and launch strategy? Because it will be harder to do it, as I said, like when you, especially as a product owner, you're going to have more stake into the product, into the experiment. So your tendency will be to launch. So that's why you should define all these things beforehand, so you don't have to go through that dilemma because you have already decided what you're going to do in any scenario that you will face. So sometimes it's like you can stop an experiment. Let's say if you ran the experiment for 4 weeks, which was what you defined in your pre-experiment, but you just want to run it for 1 more week, you ran it for 5 weeks, you still don't see anything. You should definitely do your analysis, do the due diligence, and after doing the analysis, doing the deep dive, you can conclude that the alternative hypothesis is not true. So we're going to stop the experiment and not launch. Okay, so there is one more question. So let's go into, are there any more questions? I think I see one last question. Okay, so let me go back to the slide. Okay, so the last question is, can you reiterate the relationship between type 2 and power? Okay, so the relationship between type 2 and power is that when you run an experiment, you need to have some sort of, you need to see if your experiment has enough power. And let's say if there is not enough power, but there is actually a real difference. So let's say you're running an experiment on the, let's see where, you're running an experiment on LinkedIn or Facebook profile page. Okay, and then you don't have enough power, whether because you don't have enough sample size or because your data has a lot of variance. The people that in your sample size, they have a lot of variance, or it could be your alpha is too high, or your alpha is the defined alpha threshold is pretty high. So in that case, you don't have enough power, which means you are going to say that your the results are insignificant because your p-value is greater than 0.05. However, the problem is not that there's no real difference. The problem is that you didn't have enough power, so you're not able to justify or not able to get any signals from your data that there is actually a true difference. I don't know if I'm explaining it right, but you can think of it simply that there is a real difference, but you don't have enough power because it could be any of the 4 characteristics of the power. And because of that, you are not able to get any signals on significance. Okay. So there's one more question. Post-experiment, is it statistically significant to analyze the data by creating subgroups to understand what went wrong? You should always do the deep dives. You should always do the analysis. You should do that. Obviously, you will do the high level analysis to see how your metrics are changing at the high level based on your launch criteria. For example, for Facebook, we want to get more people to post more, or we want people to engage more. We want people to like and comment. But you should also be like mindful of other things that could go wrong. Maybe are people like posting wrong contents, or is it bot traffic that is increasing? So it's always a good idea to do the deep dives and do the subgroups. And a lot of things have become so common that companies have built platforms and analysis that automatically calculate all the subgroups for you when you're trying to do the analysis. So it's always a good idea to drive as many learnings as you can, because running an experiment at once is great, but you want to be able to get the learnings out of that experiment. So the next time you come up with an idea, you are actually have some historical learnings from your previous experiment that you can apply to the next one, because you don't want to make the same mistakes, or you don't want to test the same idea again. So yes, to answer your question, it's always good to deep dive and document as many learnings as you can. Any other questions? We have 4 minutes. Okay, in that case, thank you so much for joining. I hope this was useful. If you have any questions, feel free to message me. I'll be happy to answer. If not, I hope you have a great weekend.